Hello, I am Brock Stanton. I am an aspiring meteorologist, and today we are going to be talking about 2 days of upcoming severe weather. This enhanced risk here that is for very large hail, perhaps 2 to 3 inches in diameter across mostly portions of West Texas, though areas that are also in the significant risk for hail does include eastern New Mexico and portions of extreme northwest Oklahoma and extreme southeastern Colorado. And then there is also this marginal risk across here. Let's go to the wind across portions of the mid-Ohio Valley and mid-Atlantic regions. A few instances of damaging winds and perhaps some hail is possible with that, though we're really going to be talking about this enhanced risk here, and we're also going to be talking about this day 3 enhanced risk as well. So we could be looking at back-to-back days of some fairly widespread severe weather, and there's still a good bit of uncertainty with this day 3 risk. Models aren't in the greatest agreement, but it does seem to show potential for some substantial severe weather. All hazards possible. Our low-level shear with this system is strong, so if we can get discrete cells organized out, we could be dealing with a good bit of tornadoes again. And even regardless of storm mode, I do think tornadoes are likely just because the low-level shear is going to be fairly strong with this system on day 3. We won't be discussing these really any further, but just so you know, if you're in these areas, you can maybe start taking some early precautions. There are these day 5 and day 6 risks across portions of Oklahoma, Texas, and Louisiana. So, not Louisiana and Arkansas. So without further ado, let's get back into the video, and we are first going to be taking a look at our day 2 risk on the HRRR. And as we get into the day on Sunday, we're going to see how these supercell storms fire, perhaps some clustering of storms as well. But you can see the high reflectivity outputs on these storms. That's going to be that very large hail falling in these storms, and really any discrete supercell here. Storm mode will be a little bit mixed, but any discrete supercell will be capable of hail of over 2 inches in diameter. And as we see, we're just going to play this through the rest of the day, but one of the reasons for that is these steep lapse rates we have. You can see this will continue into the overnight and early morning hours, perhaps some damaging wind threat eventually evolving with that I could see possible. But again, the main reason this risk of large hail will be so high is the combination of some discrete supercells and these lapse rates. As you can see, we're going to get into the day on Sunday. We're going to see how storms are initiating here in the afternoon hours. Low-level lapse rates of, or not, this is mid-level lapse rates. This is important for hail, 7.5 to 8.5, and that's very favorable for large hail. So that's going to be probably our biggest reason for seeing large hail being the prominent risk. And we're going to take a look at our Cape next, and we're going to see how, as we get into the day, this quarter of moderate instability is going to develop, perhaps around 1,500 to 2,000 mixed layer Cape. And again, you generally look for over 1,000 for severe weather, so that's definitely going to be sufficient for severe weather. Not quite as much Cape as what we had the yesterday, though this event really is not going to have as significant of a tornado threat for sure. Yeah, tornado threat's going to be much lower, and we'll discuss that. There could still be a couple tornadoes with that. There is a 5% contour that I don't believe I showed. There's our 5% contour in our wind. But yeah, so we looked at our Cape. We're gonna take a look at our 850. No, actually, we're gonna take a look at our moisture. This could be one of the things that does limit our tornado potential. Is that we're gonna see our moisture return is gonna be coming in very last second for this system, and the HRRR I think is probably a little bit less aggressive with the moisture return. But either way, the best moisture could be. HRRR doesn't have any good moisture with the system, period. But you can see maybe farther east is where that greater moisture that HRRR is hinting at it developing. But the discrete storms are going to be farther west, and you genuinely want discrete storms where increased tornado threat, so they're not overlapping properly right now. So that's one of the things that could limit our tornado potential with this day a little bit. Another thing is, just take a look at our 850 jet. I do think it's pretty strong. If I remember, I could be confusing days here, but let's see. Yeah, But by the evening hours, we do get while it's a little bit spotty, we do get a pretty strong low-level jet at least over 30 knots, it seems like, for the most part, by the time we get to 7 o'clock Central Time. So, again, that just kind of shows how the discrete storm mode will be earlier on, the low-level shear and moisture will arrive a little later, so that overlap for tornado potential is a little bit uncertain. But I think regardless of our tornado potential, we're going to have some chances for very large hail because of those mid-level lapse rates and at least initially discrete supercells. So, regardless, there's probably going to be a good bit of severe weather with this. Let's take a look at our bulk shear now. We're going to see, looks like we have very strong bulk shear. The 22Z storms are initiating. Here it's 50 to 60 knots of bulk shear. And yeah, overall our bulk shear is going to be sufficient. That's going to help organize those storms into supercells and clusters. So, yeah, the bulk shear is definitely going to be sufficient for storm organization. And what we're now going to take a look at is our storm relative helicity values. We're just going to see what they look like. I believe they weren't the greatest, if I recall correctly. And yeah, we can see how they generally take a long time to really increase and become as favorable for tornadoes. For tornadoes, you generally want to see SRH values above 150, above 200 for strong tornadoes, though really anything over 100 you can get at least a little bit of a tornado threat. You're going to see the overall coverage of our storm relative helicity seems to be pretty spotty on our HRRR at least, but even then this is by 2Z, this is 9 o'clock at night before our values even start to increase, and I believe our mode is a little more clustered by then. Let's just check that. Yeah, we can see look how clustered of a mode we have by then, so that just doesn't really seems to just put a huge question mark on our tornado threat. We'll look at our 0 to 3 quickly too, but it'll probably paint a pretty similar story, I would think. Yeah, pretty similar. That's all these clustered values, and yeah, these values of 500, they're kind of messed up. It's just showing like storm interference there, so it's overall kind of a messy low-level shear environment. Favorable deep layer shear, and that's pretty important for hail, but our low-level shear is a little iffy for tornado potential. You can see our energy helicity index. You can see how part of the reason this becomes a little messy is because of storms moving through it, but if we take an environment by 21Z right before storms initiate here, you can see we have our long hodograph, and that supports large hail. It's not looping too much, that's why our tornado threat's going to be fairly low at this time of the day. Also, notice how we mentioned the lower amounts of moisture. Look at the 81 to 55 temperature dew point spread. You're not really going to see a tornado with that. That's just not enough moisture. Storm bases will be way too high. But the fact the hodograph is very long will support that significant hail risk. And one more thing we're just going to look at. I didn't look at this beforehand, but just a blending thing. I think our supercell composite should be pretty high. Yeah, we can see how it does increase some a little bit later, but you can see these values here, but it's a little more messy than what I would have thought, which is kind of weird. But now we're going to take a look at our NAM. And something interesting I noticed about this setup is that the NAM kept storms much more isolated. I know I mentioned in my previous videos and many others as well that the NAM normally tends to grow storms upscale into lines, and it doesn't really do that as much, and that's kind of because it just kills the storms, it seems like. But you can see here, this is discrete supercells here. We have 1, 2, 3, 4 supercells in eastern New Mexico, and that's why the enhanced risk does expand into extreme eastern New Mexico for this chance of the storms initiating here. And we're just going to take our sounding here, and I mean, that supports some tornado. We're going to have to check and see the other things going into this, because it shows a 66 over 62 dew point. Moisture would not be a concern if that is the case. I'm just going to take a look at that. You can see, yeah, it has interestingly, NAM brings in the moisture much more. That's really interesting to watch and see how that does develop. Let's take a look at our 850 winds quickly. I was not expecting to see a sounding that strong, so yeah, I mean, our 850 winds are not that on the NAM 3K in this area, yeah, I don't see how there would be a strong tornado. Yeah, that would not be the case. Or, well, our 850 winds are not going to be strong enough, so I don't really know what it was trying to say with that sounding. I mean, there was enough curving in the photographs there for tornadoes, and at least the NAM brought in enough moisture, so there could be a tornado there if that's the case in eastern New Mexico, but I don't see how a strong tornado would happen. I just don't think the low-level winds will be strong enough. You can see, again, our 850 jet isn't the strongest. It's sufficient for tornadoes, but generally not the strongest. And I do have some question marks with moisture return, even though the NAM is much more favorable with it. Again, I do think the very large hail risk is going to be the most prominent risk factor here with this event. And yeah, again, our storm relative helicity values here, this is at 0Z, really aren't that favorable for tornadoes. Again, I say above 100 you can get a tornado, but I wouldn't really call it favorable. Really, 150 or higher is what you look for conditions to be favorable. And for 0 to 3, you generally look for values over 200 to be favorable and over 250 to be favorable for strong tornadoes. And you can see we have that on the NAM. We have the above 200, but still it doesn't seem like it would be enough to make up for a lack of 0 to 1 level shear. Yeah, let's take a look at our CAPE though on this. I don't think I ever showed that. I would think we would probably have higher CAPE than the HRR just because of the greater moisture, but we'll see about that. Yeah, see how that greater moisture is going to extend further north and west here, which is sounding at 23Z. So this one, notice how the temperature dew point spread is 19. So yeah, I think that might have just been a very localized area that we picked out on that NAM sounding with moisture. Though, again, the overall moisture is still better on the HRR. No, moisture is worse on the HRR. The moisture return is greater on the NAM. However, I do think that area of like 60 dew points in eastern New Mexico was a little bit too. It's just a very localized area that we found. We are going to take a look at our bulk shear. And we can see how, again, it's going to be very sufficient for organized storms, perhaps 50 to 60 knots. And something I don't think I mentioned is that, again, the NAM kind of just kills these storms. I don't buy that. Every other model here does develop these storms eventually up into clusters and they move eastward. So I do think that, we'll see some initial supercells early on capable of very large hail. And then we'll see storms grow into clusters and damaging winds and hail. Perhaps a tornado or two would be possible. And again, maybe as those storms cluster up, it would be more just be large hail, not very large hail. Again, large hail is a quarter size or larger. Think 1 inch in diameter, quarter size, and 2 inch in diameter is very large hail. So just that distinction in how I define those. And that's how the Storm Prediction Center defines those as well, I should say. Yeah, so just see, we're just going to show these other model reflectivity outputs quickly. I think we'll actually maybe take a quick look at some of their moisture outputs quickly, as well, just see if they're trending one way towards either the NAM or HRR. Let's see what this model does for moisture. And it seems to be much closer to the HRR solution than the NAM. We'll check it with this model as well. And yeah, mostly looks like they're leaning towards the HRR solution, so I think the NAM's probably an outlier for that moisture return. And that's why the tornado threat's still in question, just because we might just not have enough moisture to get storm bases low enough, or at least not when there's a discrete mode. That at least seems pretty likely that won't be the case, despite that NAM solution. But what we're now going to do is take a look at our day 2 risk. For that, we're going to switch back to our NAM 3K. Go back to our reflectivity output. And just a reminder for where that is. That's going to be, really our highest chance is going to be from central Oklahoma through southeastern Kansas. But that slight risk does expand anywhere from North Texas eastward through, or northeastward through southeastern Missouri. So, pretty good size area under the risk of severe weather. But as we get into the day on Monday, you can see there's these morning showers, and we'll see how that affects the instability. But the NAM does eventually develop enough instability, and we can see by the end of its run here how it fires these storms along. There's a cold front up here, and that's what's initiating these storms. And then maybe there's a dry line back further west. Let's just check that. See if we could... Yeah, so there's going to be a cold front to the north, and then maybe a dry line to the west, and that could help initiate storms. You can see there's, on the NAM 3K, there's a very strong moisture return for this. Now, I don't know about dew points in the 70s. That seems a little aggressive for southern Oklahoma, but this mid to upper 60s dew points does seem a little more reasonable. So that would supply our more than enough moisture to get our surface-based thunderstorm development. But next step is to take a look at our Cape. And we're going to see how, maybe because of those morning showers, the eastern axis of it is a little more certain. We can see this hole because of those morning showers in our instability. But that along into the east of the front, we're going to see how there's going to be this more than sufficient Cape. If we take a sounding in here, let's see what it is. There's our turning over hodograph. It's not that big of a hodograph yet. There's some turning there that would support that tornado risk. And I will say that it does really, the low-level shear values are going to be pretty strong. You can see throughout the most of the day here. And I think we're going to show that by looking at our storm relative helicity values. And we're going to see here that even on the NAM, even by 21Z, that at least the NAM still has these storm relative helicity values over 200. Again, 21Z, that's going to be 4 o'clock Central Time. So, again, I do think that if this NAM solution does come to form, that even if our mode is going to be a little more linear, which I do find to be reasonable along with the cold fronts of forcing mechanism, at least further north, I do find that a line of storms is going to be likely at some point, that we could even then still see a tornado risk, perhaps even somewhat of a widespread tornado risk as well, just because when our low-level shear values are so strong, and I'll show that with our 850 jet here in a second as well. Again, our low-level shear values, our 0 to 3s are going to be over 300 or even over 400 here. So that's just going to support that tornado risk really as long as you have a surface-based thunderstorm. And show our 850 winds, very important for our damaging wind and tornado potential. On our NAM, which we're going to see here that over 40 knots in each quarter of over 50 knots, and how that's going to increase and expand. See here, there's our line of storms there. And this just shows how our environment's going to be favorable, quite favorable for damaging winds and tornadoes here. See on this sounding here, there's a pretty weak capping inversion, so storms should be able to break through that, at least with the cold front. We'll see about these storms further south. Just going to take soundings here, see what they were looking like. Further north, there might be a bit stronger of a capping inversion, but there's still these storms ongoing that would support that risk for damaging winds. And just take a look at our capping inversion on like a broader scale here on the NAM. And we're going to see how it generally weakens a good bit during the day. Maybe not completely, though. It's just going to have to watch exactly how much this capping inversion weakens and how much these morning showers do affect the output. But I do think there is a chance for some pretty significant severe weather here. All hazards will be possible, and depending on how the storm mode works out, how the capping inversion plays into it, that's really going to determine what what hazard will be the most widespread. That's kind of still up in the air. We still do have like a day or two to figure that out, but I do think all hazards will be possible with this. And just to kind of show the uncertainty, we are going to take a look at some other models here. So now with GFS, we're going to look at the moisture first, and we're going to see how that our dry line's right here, but if you look at our temperatures here, our cold front is going to be further to the northwest here. So, and the GFS does not convect the dry line, so I think the GFS probably has a stronger capping inversion in place. We're going to check that. And, I mean, at least by 21Z, not really. So I do think that despite, again, so the coverage of storms might be a little different, might be a little further south. maybe not as much in Kansas, but maybe more just in Oklahoma on this particular run of the GFS. But the fact that it shows this dry line here and there's no cap in place would suggest the storms would fire across central Oklahoma here, posing a risk for all hazards. That's what the GFS is telling me. Let's see what the Euro says quickly before we end this video. We're going to take a look at our moisture first and just see how that looks like again. We can see how it has our dry line right here. Let's see where our cold front is. And so our dry line's right here, our cold front's here. So I do think of it, and you can see it by 3Z, it looks like the cold front catches up to that dry line, but I want to look at the capping inversion now and just see what that shows quickly. And the Euro has a much stronger cap in place that might preclude thunderstorm development before the cold front comes in. Whereas I never looked at the lapse rates for the setup, I just want to see what it looks like to determine the hail potential if we get a discrete storm. So the NAM has really good lapse rates, it looks like. The Euro, not as much. Now for the GFS. And GFS had pretty good lapse rates there. Look at it for a second there. So I do think that significant hail would be a possibility with any discrete supercell. Again, our storm mode's still a lot of question marks, but overall I think a lot of the ingredients are going to be there for severe weather across portions of the southern plains on Monday. But we still, and I'll try and tell this to you in the video tomorrow, where I think exactly where it's going to be. But overall the setup for the most part does seem pretty favorable for severe weather. We just need a pinpoint, is it going to be, is damaging winds, hail, or tornado going to be the biggest risk, and we need to figure out where that's going to be. So I will see you in so that will be my video tomorrow discussing this, and then probably talking about the, maybe a little bit about the day, what will be the day 5 risk then as well. But I hope to see you then, and I will see you next time. Bye.